In this video, we're going to talk about compound interest. We're going to use a couple different formulas. There's always two basic formulas you can always think about. We'll talk about those. If you haven't already watched the Euler number video, you might want to check that out. We're going to be using the value E in at least one of these equations here. So hopefully you're familiar with that. The first equation talks about things being compounded a certain amount of times per year. And I'll explain that in a sec. Let's just write the formula down. We're going to have a lot of variables, and it's important to know what they represent so that you can substitute correctly and get your answer. So let's say I go to the bank and I deposit a certain amount of money that I want to just sit there and collect interest and make me money just by sitting in the bank. That amount of money that I put into the bank is going to be represented by this letter P, which stands for principal, but more simply it's just the initial amount that you put in, or your starting amount, initial amount. A is going to represent what comes out. So you can think of A as your answer. That's the easiest way to think about it. So if we move across here, we got R and N next. R is going to represent your rate of interest. So R stands for rate, so that's kind of easy to remember then. Rate of interest. And a lot of times they're going to give you that rate of interest as a percentage. You want to convert it to a decimal so that you can use it in your equation. So make sure it's a decimal amount when you go to figure out how much money you got. N is going to represent this thing called the compound amount. So N represents the number of times your initial amount is compounded. So the number of times it gets compounded per year, and that's important. So we can have a few examples. Annually would be the easiest one. So if something is compounded annually, it only happens once per year. So compounded once per year. It could happen biannually. Bi being a prefix that means two. So biannually compounded would be compounded 2 times per year. So I would substitute the value 2 for N. We could also have a quarterly compound. Quarterly would happen 4 times per year, so I'd put in a 4 there. We could also have monthly. If something is compounded monthly, then how many times would that happen per year? So compounded monthly would be 12 times per year. You'd put a 12 in for N. So there's a lot of different values that you could put in. I mean, daily, I don't know if that's a real compounded value, but maybe you'll see a problem where they say daily, and so then you would use 365 as your value for N. So this is always how many times does it get compounded per year. Monthly, biannually, or annually are usually the most common values. So there's 2 spots you're going to put that number. You're going to put it there and there. The same amount's going to go in both spots. T is going to represent the time, or really what it represents is the number of years that this is happening. So N is going to represent how many times it happens per year. T is going to represent how many years it happens. And you should be given all of those values in a word problem. So if you can substitute your values correctly, convert a percentage to a decimal correctly, and then use your calculator correctly, these should be fairly easy problems to do. If something gets compounded continuously, and that's a different type of problem. So if you watch that Euler video, the Euler number video, you recognize this expression here is how we got the Euler number, and we figured out that if this expression, if n gets closer and closer to infinity, or as it gets bigger and bigger and bigger, this whole expression gets closer and closer to the value e, or that decimal 2.718. And so if n, if the number of times it gets compounded per year is infinity, or as close to infinity as we can get, then instead of using this expression, we substitute that entire expression for e. So we would use this formula instead. Instead of all of this, we just simply put e in its place. And instead of n times, we don't care because it happens continuously, we're just going to use r, or the rate of interest, multiplied by the amount of years. That's going to be our exponent that we raise it to. And then we got our continuous compound formula. And we'll see how to use all of this next. Alright, so hopefully you wrote all those down. I'm going to be moving kind of quickly through the next problems here. So let's use these two formulas, see when we use each of them, and how we can compare them. So we got this first example. If you invest $9,000 at an annual interest rate of 2.5% and it's compounded annually, find the balance in the account after 5 years and state the amount of interest earned. So let's take it one step at a time here. Let's figure out what each of our variables are in this problem. So this is our P, our initial amount that we invest. So instead of P, we're going to substitute 9,000. We know it's compounded a certain amount of times per year, so I'm going to be using that first formula. So I'm going to say 1 plus, we're going to have R over N. So let's figure out what our R is, our rate of interest. Our interest rate is 2.5%. So this is our R right here. But remember, we have to convert it to a decimal. So as a decimal, I'm going to move my decimal point over 2 spots to the left to convert it to a decimal. So I get 0.025. 0.025 is the decimal equivalent. On the bottom, I'm going to use n, so the number of times that it gets compounded per year. Well, it says it gets compounded annually, so that's only once per year. So I'm going to substitute 1 for n. I'm going to do it again up here, 1 instead of n. And then in t's spot, I'm going to represent the number of years that this is happening. Well, it says it's happening 5 years, so that's our t. Alright, so you can simplify a little bit if you want. 1 times 5 is obviously going to be 5, so you don't have to use both values up there. You could just put a 5. And if we use our calculator, a lot of scientific calculators or graphing calculators, if you just plug this in as is, it's not going to give you the correct value because it doesn't know necessarily what to do first. It doesn't know its rules. So you'd have to use a little bit more parentheses. So I always recommend that you just work inside out, and your calculator should be able to handle this if you do it one step at a time. If you do this division first, and then add 1 to that, and then raise that value to the 5th power, makes it a lot easier. Your calculator should be able to handle that. So divide this by 1, add 1 to that answer, raise that answer to the 5th power, and then multiply that answer by 9,000. You should get 10,182.67 approximately. I'm rounding my cents off here. So check your work, see if you get the same answer. Pause the video if you need to. So this is the amount of money that's sitting in the bank after 5 years. So I put 9,000 in the bank, I let it sit for 5 years. Now magically I have $10,182.67. So how much money did I earn just from having it sit in the bank? That's called my interest. What's my interest amount? Well, if I subtract my new amount by my initial amount and figure out what the difference between the two is, then I can figure out how much interest I earned just from having my money sit in the bank. So if you do that subtraction, you should get $1,182.67. Okay. So that just happened. I earned that from having my money just sit in the bank. You can also figure out how much interest per year you earned. And kind of important. We'll need that later. So interest per year, per being the key word there, meaning division. So if I divide this amount, my interest amount, by the number of years, I can get my interest per year. So if I do $1,182.67 divided by 5, I should get my amount of interest earned per year. So when you do that division, you end up getting $236.53 approximately. So each year for 5 years, with my money sitting in the bank, I'm earning an average of this. I mean, it's not going to be this exactly every year, but it's going to be close on average every year I earned that. And so it added up to 1,182 after 5 years, and that was added to my initial $9,000, gave me a total of $10,182. So a fairly good investment, earning almost $1,200 just from having your money sit in the bank for 5 years. Let's do another example here. This time I'm investing $8,000, so that's my P. Can't see it there. There we go. P. Stop it. Alright. This is my R, my interest rate, as a decimal, remember, so let's convert it to a decimal. And here's my N, compounded monthly, so my N is going to be 12 times. That's how many times it happens per year. And my balance in the account I want to know after 6 years, so 6 years will be my T. And then we'll figure out the amount of interest and the interest per year. So let's substitute into our equation our values. 8,000 instead of P. Instead of 7%, I want to use 0.07. And instead of N, I want to use 12. Monthly happens 12 times per year. And again, 12 up here. Now with T, and T was 6. So you can simplify this first and write a 72 up there if you want. And then do the math. So we want 0.07 divided by 12 first. We're going to add 1 to that answer, and we're going to raise it to the 72nd power. And then we're going to multiply that answer by 8,000. So again, you can pause the video and do it yourself. Or you can just follow along and trust that you get $12,160.84, rounding. So that's how much we earned from it sitting in the bank. Now we got $12,160. If I want to know how much I earned just from having it sit in the bank, we subtract these two values, because we provided the 8,000. Now we have this much. So how much did we get from it sitting there? It's called our interest amount. If you do the subtraction, you should get approximately $4,160.84. Sometimes you can do that math in your head there, it's not too hard. If I divide that by the number of years that I did it, so my interest per year, then each year, how much did I earn here? What's going on here? Interest per year. So 4,160 divided by 6 years. So when we do the division, we get about $693.47. That's how much we earn each year for 6 years to give us this amount. So fairly good investment there. Next problem is comparing two of them. So if you do this process twice and then compare your interest per year values, you can find an option that gives you your better investment. So I'm going to let you look at this. I'm running out of time in this video. Go ahead and pause. You can do the problem yourself. I'll let you know that the second investment there is going to be the better deal. So at the end there, if you check your answer, make sure that your interest per year value is better for that second option. I can go ahead and make a video doing this. You can check it out later. I'm out of time. I'm sorry.